This conference will now be recorded.
Hi, good morning everyone. Welcome back. So you can see the screen, right? Abhishek, funny, can you see the screen?
Sure.
Yeah, okay. So now let us continue. In our last class, we are discussing the RoboShop project, and we make the UI layer front end, and then back end we installed a user and we connected with the UI layer through reverse proxy. Whenever there is a request on /API/user, the front end will send the request to the user container, and it needs MongoDB to store the user data. And similarly, we installed catalog and then we added to the cart. And so till this we discussed. And then after adding to the cart, they want to place the order. We need shipping information and payment. These two are pending. And as you see in this diagram, I have created the dependencies between the containers as well. And the same thing we are doing in the Docker Compose file also. Okay, so like this, I started the server and let us run the Docker Compose again. Now it is running. Web is not running. Maybe some configuration of it. Okay, I added some information for testing. I will remove this. We haven't completed, right? So I'll comment this part. Now it started. Let us check Docker PS. Web still not started. Again, something Docker logs. Okay, but still it is. Pull the code. Okay, I'm usually forgetting this. Whenever you do some change in the image, you need to rebuild that image here. Okay, let me go to the web. Docker build -t web:/v1 dot. Now you do the Docker compose again. Okay, now started. Our web got started on port number 80. Let us take this on port number 80. Login. Okay, maybe last week we gave the same information. Okay, now we got it logged in, and then let's go to products and add to the cart. Cart is added. Now we want to check out. Now we need shipping information. What is the country and which location you want? It should come from the database. So that database is MySQL here. So you should have MySQL, then shipping. If you install shipping service, shipping will get the data from the MySQL. Okay, now we need these two services. Let's go to shipping here. It's a Java application. If you see pom.xml and Java files, and then it would be connecting to the city, and then it need to fetch the cities from the MySQL database. So we have MySQL also here. This is a container. And if you see this, we are getting MySQL 5.7 version, and then we are giving few this one, root MySQL giving empty password, so other applications can connect to this database without any password. And we are creating one cities database and one user shipping and password. So these two things are for the shipping service to connect to this database. Okay, and then there is something called Docker entry point init b this folder. Whenever Docker is running, if there is some files in this folder, Docker will run those files before the container gets started or container gets created. So whenever we start the database, we need some default information like what is the country, what are the cities in that country. All those informations we need to store it into the database actually. So for that purpose, this is like init script. Okay, so this one is a dump. I extracted this dump, then the dump will have this one, cities dump. Okay, you see it is creating a cities table, and then inside that cities table, it is running lot of insert queries. It is very long file because all the countries information and all the cities in that country is available in this SQL file. So what we are doing, we are taking the MySQL server and giving some passwords and running some few init scripts to store the cities and countries data. Okay, this is a very large file. It takes some time to load. So that script, we made it as a zip and then copying it into the Docker entry point init database.d directory. So this is from the MySQL image. If you see this, so you see this .sh or .sql, .sql.gz files that are found in this directory will be executed before starting the container. Okay, now it is loaded. You see lot of insert queries we are running to store the cities and countries information. Okay, that's what we are doing. Let me copy this to our project. Okay, MySQL, just we don't need this volume, and we don't need this as well. Okay, so that's it. Taking the database container and initializing it with a few SQL scripts. Now I will pull this. Okay, cd mysql docker build hyphen t mysql colon v1 dot. Okay, we are able to create the image. Now let us give it as a container in our docker compose. MySQL image MySQL container name MySQL. Now run docker, sorry, shop docker compose up hyphen d. Okay, our MySQL is running. Let us try to log in. Docker exec hyphen it bash. Give MySQL show databases. So we got the cities information. Use cities database and then show tables. We got cities and then codes. So the information is already loaded into the database. Now to fetch this database, we need shipping service. Data is ready. The information will be read and then provided to the user by shipping service. Now let us add shipping as well. This is a Java application. Now you see the use of microservices is one application can be in Node.js, another application can be in Java, another application can be in Python. All you need is I will hit your service, I need data, but I don't care which application you are it is developed. So that is the advantage of microservices. If it is not microservice, if it is like monolithic RESTful services, then the entire application need to be developed in only one programming language. Okay. So that is then you need entire Java team or entire Node.js team. But here you are independent of the language. Now, if you see this Docker file, this is called as multi-stage build. We will discuss what is multi-stage build in Docker. That is very important. For now, let us run this, and by the end of the session, we will discuss what is multi-stage build. Okay. Now, no need of any changes. We will discuss this. Just build it for now. cd shipping docker build hyphen t shipping colon v1 dot. Okay, so we built the image. Okay, I think last time I built it, that's why it was very fast. Let me remove and then show you. Docker rmi docker remove image and then image id. Okay, now build it. Still very fast. Okay. Let me remove all the containers. Docker rm-f, docker ps-a-q. Okay, so these images are in cache. Now actually I need to remove a lot of images. Okay, so for now let just think this is already built. I will show you why it will take a lot of time by the end of this session through the Docker builds. Now we have the shipping image which we already built it. Now we need it through the Docker Compose. Shipping image, and then shipping container name is also shipping, and we need to change our web Docker file configuration. Whenever there is an /api/shipping, just send that request to the shipping service. Now we changed web, we need to build it again, and shipping we are doing already. The dependency for shipping is MySQL. MySQL should be there to run shipping service. Okay, and web also you can use the same shipping. Okay, that's it. Let us push it. Rebuild the web docker build -t web v1 dot. Okay, now docker compose up -t. Okay, all containers started. Web user cart redis mongodb catalog, but we don't have the MySQL and then shipping. MySQL exited. Let us see docker logs. Let me check the ship pull again. Build it, and then now docker compose. Repository does not exist. Shipping shipping is there. Docker build -t shipping v1 dot. Okay, shipping is found. Shipping v1. Okay, we need to give v1 here. Just push it. and then git pull. Now you run docker compose up -d. Now check docker ps. Web is running, shipping is running, user, cart, Redis, MongoDB, catalog, but MySQL is not running. Let us see what is wrong with MySQL. Docker logs. You need to specify one of the following. We already specified MySQL allow empty password is all yes. Okay. The problem is here also you need to mention v1. Otherwise, what it will take is it will get the image from the MySQL Docker Hub, that is by default 5.8 version or MySQL 8 version, the latest version. But we used here MySQL 5.7. We built this image and we named it as MySQL colon v1. Since I forgot here to give colon v1, it is pulling it from the internet. Okay. Git pull. Now you run docker compose and then docker ps. All our services are running. Now let us go here and then hit our shipping. Okay. Each time it may lose the data because we are not storing the storage. Just register again and again. Add to the cart, come to the cart, check out. Now you see we are getting the information. Okay. We calculated the distance, cost, and let's confirm to place the order. Pay now. Now this is payment service. We don't have installed it. Now we need to install the payment service. So for payment service, the payment information will be stored inside the RabbitMQ. Okay, first we need RabbitMQ and then that payment needs that RabbitMQ to store the payment information. So now let us go to RabbitMQ. RabbitMQ is we no need to do anything, just build like Redis and RabbitMQ. Just give here RabbitMQ. We no need custom image for this. Image RabbitMQ and then container name RabbitMQ.
RabbitMQ is for what purpose? Could you please explain that?
Actually, this is the messaging. RabbitMQ is messaging. Usually we hit the other application through HTTP, right? If the other application is not running, we will get the error. But this is a payment information. If the other application is down for at least 1 or 10 seconds also, we will get the payment error. So what projects will do is they will run a queue kind of applications. RabbitMQ is a queue kind of application. For example, I sent you a WhatsApp message. You are not online, but you will get the message whenever you come online. So same, other system is down, but I should not lose the payment. So this is called queuing. Like you are offline, the message should not be failed. So what will happen is the message will be in the queue. Whenever you come online, then the message will be delivered. Same kind of application here. the payment information will be sent to a queue. If the other system is like payment system is up and running, like banks, credit cards, and something like payment, Google Pay, Phone Pay, when they are up and running, the message will be delivered. If those systems are down, the message will not be lost. It will stay in the queue. So that is called as asynchronous. There is two kind of applications, synchronous and asynchronous. Synchronous means both applications should be in sync. It should be up and running. Asynchronous means if the other application is not running also, your transaction will not be lost. It will stay in the queue. When the other system becomes online, then the message will be delivered. So these things are called as MQ kind of applications. Okay, messaging queue like Active MQ, JBoss MQ, IBM MQ. There are a lot of queue kind of services available. RabbitMQ is one of the open source.
Okay,
Okay,
thanks.
yeah. So now let me pull. Even myself is confusing while creating the images, pulling and then pushing. So for you, just practice this. Anyhow, we don't use Docker in the practical purpose. We go with Kubernetes, but still for the practice or purpose of Docker, just remember whenever you are not getting something, just think whether you pull the changes and you rebuild the image or not. Okay. Now Docker compose up -d Docker ps. Your RabbitMQ is running. I'm just getting the image from the internet because I don't need any customizations in this. But here we need some customizations. I'm referring :v1. Okay. So RabbitMQ is running. Now we need payment actually. Just get the payment from the open source. This is a Python application. You can see here .py and Docker file. If you see, we are getting Python 3.9 exposing 8080, getting the root access. You can remove this. Setting the work directory to the /app. Requirements.txt in Python is just like package.json in Node.js and pom.xml in Java. Here you will mention what are all the dependencies you need. Then Python will pull it. Okay. And we are installing the dependencies like npm install. In Python it is pip install. And this is our code payment.py and rabbitmq.py. We see payment.py. This will be getting the information from the cart user and then RabbitMQ. So our host should be RabbitMQ. So that is why I am giving the container name as RabbitMQ. Okay, if you change this, then this will not work because payment information is calling the RabbitMQ with name RabbitMQ. Okay. Copying the files and copying the files, just running it. That's all. So you know all these instructions already. Push it. Pull here. Okay. Go to payment. Docker build -t payment :v1 dot. Okay, done. Now we need to modify our web application to do the payment configuration. Okay. And then Docker compose, give the payment information. Payment. What is the image? Payment colon v1. Container name is payment. Okay, and this depends on RabbitMQ. Okay, finally your web application is dependent on everything. Okay, I already mentioned payment here. Now I change the web. I need to pull and then rebuild. Docker build -t web colon v1 dot. Rebuild is done. Now Docker compose up -t. Docker ps. Now payment is running, web is running, everything is running. Let us do logged in, go to something, add to cart, checkout, get the shipping information, confirm, pay now. Now you see the payment is sent the message to the RabbitMQ and they said the order is done. Now you go here and check your order history. Okay, this is the sample microservice we built with Docker and Docker Compose. The same application we will install into the Kubernetes cluster. This is the ideal microservices application for the practical purpose. Okay, now you go and see. So all the services are here. Just understand this dependency and the Docker files. You don't need to understand about the applications in depth because this is done by developers. Okay, now we will discuss few things about the best practices in Docker. Docker image layers and then multi-stage builds. So these two are very important concepts. You face some questions in your interviews. Now let us discuss Docker image layers. If you go here and then check anything like command. So what are the layers in Docker? So layers is like each instruction is a layer here. For example, from Alma Linux, this is layer 1. This is layer 2. This is layer 3. This is layer 4. What you are doing here is you are getting one base image. On top of base image, you are updating something and you are installing something. And then finally, you are giving a command to start it. So now let us get this and then do what it is. I will just copy this into our Linux server. Hit clone. cd_cmd. Now let me build and then show you. Docker build -t cmd:v1 dot. Now Docker images. Our CMD has 317 MB. So when you are increasing the number of instructions, the memory of your Docker image is going to be high. But what is the Alma Linux 8? 189. So on top of 189, you added this much memory to it by installing something. Okay. Now, so what happened here? First step 1 by 4, because it has 1, 2, 3, 4 layers. It is pulling the base image. Now you see here, downloaded newer image for this one. And then this is the image. And then on top of it, it is running m-update-b, running in something. Now what is this is? This is Alma Linux. I need to update something as a second instruction. What will happen is Docker pull this image and it will create a container out of it. This container is Alma Linux container. This is called as intermediate container. Okay. And then it runs this m-update-y. Okay, here it runs m-update-y. This is a container, and what it does is it creates an image out of it. This is image up to this much. Okay, and then this image will be, for the third step to run, this image will be again creates an intermediate container. Okay, I can say this as layer 2 container. This is layer 2 image. And from this container, what it will run, yum install nginx-y. So this is little confusing, but I will make it clear. Okay, now layer 3 is done. Now it will create a image. To run the fourth one, this is layer 3 image. To run the fourth one, it will create again one more intermediate container, like layer 3. and from here it will run the final CMD. And from this it will create the final image. Okay, so just this one. Okay, after this class I can create a good image and then post it. Okay, so this is the final image. So I will repeat once again. First it will download the base OS as image. It will create a container. From this it will create a container. Okay, and for example container A. Yum update will be done inside container A. Okay, then image B will be created from this container A, and that image B will run as container B. Yum install command will run inside it. This will be taken as image C. Okay, to run this fourth instruction, again container C will be created from image C. Run CMD in container C. Okay, once this is done, take the final image. Okay, so all these things here are intermediate containers. They are read only, but this is final image. This is read write image. Okay, any doubts?
Yes, Eva. In this file, we have three instructions, so it will create three containers in between. So
Yeah,
in case if out of these three commands, in case one command fails, means it will stop at the process or it will continue the workflow
it will
further.
stop. Just like when you are running something in between, if you're writing a program, in between if there is an error, the program will be stopped, right?
Correct. Yeah.
Yeah, here also it will be stopped. But what I want to say is how the Docker image is built to the final image. It's a layer approach. Okay,
Yeah.
so this is one layer. Yeah, you got that right?
Yeah. Got the point. Yeah.
Yeah. So these are the Docker image layers. Same if you see in internet, same thing will be explained. Okay, so this is the base image. From this base image, a container will be created. Why a container will be created is to run this something, you need a container, right? Because that is the running one. A container will be created from layer 0 base image. This command will run. Layer 1 will create. Again, layer 1 will be taken as image 1, and then image 1 container will be created here. Then this command will run. This will become image 2. Again, image 2 will be created as a container, and then the final thing will run. You got the concept?
Yeah. Clear.
Yeah. Okay, so this is the Docker image layers. If you are writing more layers, what will happen is the build time will be more. And similarly, on the other hand, when you are pulling it, the pulling also will be late. And your memory also will get increased. Okay. So across the world, lot of people are running Docker builds, creating lot of images and then storing it into the Docker Hub. How Docker Hub is maintaining that much memory? Because Docker will not store your image as like this. Docker will store your image as layers. Okay, if you see this Docker inspect, you can see the layers here. Each layer belongs to one container, one intermediate container. Okay, when you are pushing this Docker push cmd colon v1, when we are pushing to the Docker Hub, let us see what happens. It is pushing the layer by layer. Okay, I need to log in first. Docker login. Now you push. Again access denied. Why? Okay, I need to use my username. Okay. Before that, I need to tag Docker images, Docker tag cmd colon v1 as techie trainers slash cmd colon v1. Tagging is nothing, just for the pushing purpose. Docker push colon v1. Now you see the pushing is through the layer, not through the entire image. First it is pushing this one, but it didn't push. You see here, all the other three layers are pushed, but the base image is not pushed because I am referring it to the Alma Linux 8 open source image already is there in Docker Hub. Then it checks this layer is already exist in my system. I don't need to push it again. I will just refer it to this one. Okay, sorry, that is it. 130. So these three layers pushed actually. So while pushing, we missed that line, I think. Okay, it is not showing that line because we pushed these. It pushed only these three extra containers, but it didn't push Alma Linux because it's already exist in the Docker system. Okay, now I will do something. I will just do some change here inside Docker file. Before here, I add something and echo hello world. Now another layer will be created. I will do it as docker build -t cmd colon v2 dot. Okay, now 5 layers are created and let us inspect this docker inspect. Docker images. Docker inspect. I think this is since just an image in the background. So just running it on the thing. Let me install something. Yum install. For example, gcc-y. Okay. Docker inspect. Now you see we got an extra layer, because earlier that was just displaying a message. It didn't create that layer. Now we got an extra layer, but if you check this, let me copy this and then what is the layer for v1? Docker inspect. See, the first one is already there, second one is already there. We got just one extra layer. Okay, but in between, if you change something, the underlying layers also will change. If you see, till this the layers are same. This one is same, this one is same, and from here it got one extra because you added something extra line. Now if you push it, docker push. Okay, before that I need to tag docker push cmd:v2 as techie trainers /cmd:v2. So docker tag and then docker push. Now you see here, you can see layer already exists, and then it is pushing the extra layer only 376CA. 376CA. This is the extra layer, then it pushed only that layer. Okay, this is the layer approach in Docker images. Now you will face like explain the Docker layers, what are the intermediate containers. You should say whenever there are some instructions, Docker will create a container out of base image, and on top of it, it will run the second instruction. Again, it will create another image. Again, it will start another container. So like this, it will goes on. And the Docker, while pushing the image to the Dockers, it pushed the layers, not the exact image. If you are referring the same layer again and again, then simply it will not do any action. It will refer to the previous layer. Okay, any doubts? This is same like checksum concept in file system. Okay, now if I take this md5 sum docker file, there is a ID. This is checksum ID. Every file will have a checksum ID. Okay, if you change the content inside even a single character, then the checksum ID will be different. For example, I am inserting a U here. Now you do the checksum md5 sum. Now you see the checksum got changed. So the same concept here also. Until you don't change the content in the layer, the ID will be the same. The layer ID will be the same. Then Docker refers it to the previous one. If you change something in between, then the ID will be changed. Then Docker will consider it as a new layer. Since till here, in our earlier, till here, the things are same. So it refers the previous layer IDs. From here, it is getting changed. Then the everything will got changed from here. Any doubts? So got the concept?
Yes, you are clear.
Okay. So this is very important thing to understand and explain it in the interviews also. Okay, whatever I told you, then I will write it as a document and then push it into our remote repository. Then tomorrow's class we can discuss about multi-stage build, and then we can start our Kubernetes tomorrow itself. Okay, if everything is clear, then that's all for today.
Yes, Siva, I have some question.
Yeah,
This dot YAML syntax. I'm not aware of that previously. Do you have any material for that? Like any videos in YouTube or something like that, which
no,
will
I'll
teach about?
explain tomorrow. I will explain tomorrow's class. Like when we are writing YAML syntax, I can explain how to write.
Okay, fine. Okay. I'm not fully aware of that. Only the basic thing what you need for that YAML. I know that, but
It's okay. That is very
sometimes
simple. I will explain you.
we do mistakes. Yeah, yeah. And another thing is this for the CK exam. Sorry, I know the expansion. The thing is there are two streams. Is that right? One is admin, one is developer. And
Take the
I'm planning
admin.
to,
Admin is
yeah,
developer
correct.
plus extra.
Yeah. So is there any zone? Generally, they will give some offers in between some periods, no,
Okay,
for
we
the
will
day.
discuss this thing. We will discuss this thing offline about the
Okay,
exam.
fine. Okay, thank you,
Okay.
Siva. Nice.
Yeah. Have a nice day. See you tomorrow.
Thank you. Bye.